I'm Quincy.
And I'm Allie.
And today we're going to be talking about
the derivative at a point. The definition of a derivative is given by the limit as h approaches 0 of f of x plus h minus f of x all over h.
a function f of x is only differentiable at a point x if the limit exists at that point x. The derivative represents the slope at that point. We can use the derivative to find the instantaneous velocity or the instantaneous slope at the exact point.
So let's say we have a graph f of x in blue, and we have a point C right here, C f of c on the graph f of x. And we want to find the derivative at a certain point, f prime of c. So by knowing looking on the graph, you can see at point C, the tangent line would look something like this. And this line represents the derivative of the function at point C, or f prime of c. By knowing this value, f prime of c, we can estimate and we can know the value for the slope of the tangent line in red.
To graph the derivative of a function, you find the slope estimate the slope at each different point. Here, where the slope of f of x is 0, there would be a point at 0 for the slope is 0, and the same thing here. Now, since the f of x is increasing, the slope of f of x is positive and increasing. Here, the slope is decreasing and getting more and more steep, but right here, it starts getting less and less steep. On this side, the slope is increasing. Derivative is always positive where the slope of f of x is positive.
So basically, when you're graphing the derivative, you want to focus on where the function f of x has horizontal tangents and where the slope is positive and negative.
So far we've covered the definition of a derivative, what the derivative means and how it can be used, how to graph a tangent line, and how to graph the derivative of an equation of a function.
So now, let's work on some example problems to apply your knowledge.
Good idea, Allie.
Alright, example problem number 1. f of x equals 2x squared minus 6x plus 8. Find f prime of x using the limit definition.
The limit definition, as we went over in the earlier section, is this. So to find the f prime of x, you use this equation for this. 2x plus h squared minus 6x plus h plus 8 minus 2x squared minus 6x plus 8 all over h. Next, simplify this out and cancel it. The 6x's cancel, and so do the 8's.
So you want to multiply out everything you can so that you don't have any parentheses, and usually things will cancel out so that it'll be simplified and you can divide everything by h.
Next, you plug h in for 0. You plug in 0 for h, and you get 4x minus 6.
Alright, problem number 2. If f of x equals 3x squared minus 5 cubed, find f prime of negative 1. So our first step is to find the derivative, and to do that we're going to have to use the chain rule. So f prime of x equals, and we're going to have to bring this 3 down, and then square that, because we have to minus 1 at the exponent, and then multiply that by the derivative of the inside, which is 6x. So let's simplify that a little bit more. Alright, now we want to find f prime of negative 1. So all we have to do is plug in negative 1 for x for this derivative equation. So it's 18 times negative 1 times the quantity of 3 times negative 1 squared minus 5 squared. And that equals negative 18 times 3 minus 5 squared. So let's move that over here. And that's going to be negative 18 times negative 2 squared, which is going to be negative 18 times 4, which is
negative 72.
Negative 72. Thank you, Quincy. And that is our answer, which is actually a very steep slope, but that is the slope of the tangent line at the point x equals negative 1 for this function.
Ta-da! Here's how you would do that on a calculator. To find the derivative, you press second, and then this, where it says derivative right there, d over dx, and then you plug in your equation. So 3x squared minus 5 cubed when x equals negative 1 is negative 72, so you can check your work. Our next problem is find the equation of the normal line to the graph y equals 2x plus 3 over 3x minus 2 at 1, 4, 5. First, you need to find the derivative of y. So y prime, by using the quotient rule, y prime equals low d high, so 3x minus 2 times the derivative of this, which is 2, minus high, 2x plus 3, d low, which is 3, all over the bottom squared. So 3x minus 2 squared. This simplifies once you multiply it all out. 6x minus 4 minus 6x minus 9, so these cancel out, all over 3x minus 2 squared, which equals negative 13 over 3x minus 2 squared. Next, you plug in the point 1, 5 to this, so the x is 1, so when x is 1, the slope is negative 13 over 3 minus 2 squared, which is equal to negative 13 over 1, which is negative 13. The question asks for the normal line, which means the perpendicular line. So the perpendicular line would have an opposite reciprocal slope. So the slope of the equation would be 1 over 13. And the equation would be y equals 1 over 13x plus b. And so you plug in the point 1, 5. B equals 4 and 12/13. So y equals 1/13 x plus 4 and 12/13. And that is the equation of the normal line to the graph.
Thanks for watching. Hopefully you learned more about finding the derivative at a point and how to use it in calculus.